How would you feel if you woke up one day to find the sun, the very heart of our solar system, had ballooned to a size so vast it swallowed the Earth whole? That's the dramatic fate awaiting our sun in about 5 billion years when it transforms into a red giant. But what exactly is a red giant? And why does it hold such a fascinating allure for astronomers worldwide? Red giants, as the name suggests, are giant stars, but their color is not always red. They can range from yellow-orange to red, depending on their temperature. But before we get into the details, let's understand the life cycle of a star and how a red giant fits into this celestial narrative. Every star begins its life as a nebula, a large cloud of gas and dust. The gravitational force in this nebula pulls the gas and dust particles together, creating a protostar. As the protostar continues to grow, the pressure and temperature at its core increase, eventually leading to nuclear fusion. The fusion of hydrogen atoms to form helium releases an enormous amount of energy, marking the birth of a star. From here, the star enters a long period of stability known as the main sequence phase. This phase can last from a few million to several billion years, depending on the star's mass. Our sun, a medium-sized star, will spend about 10 billion years in this phase. As the star exhausts its hydrogen fuel, the outward pressure decreases, and the star begins to contract under its own gravity. This contraction increases the core's temperature and pressure, triggering the fusion of helium into carbon and oxygen. This phase marks the beginning of the red giant stage. The outer layers of the star expand due to the increased energy output from the core. The star grows in size but cools down, giving it a reddish appearance, hence the name red giant. But the life of a red giant is not a calm one. The core continues to contract and the temperature keeps rising, leading to the fusion of heavier elements. This process continues until the core is filled with iron, a stage where fusion can no longer occur. The star's fate now depends on its mass. If it's about the same size as our sun, it will shed its outer layers, leaving behind a white dwarf. If it's significantly larger, it ends in a spectacular supernova explosion. So, to recap, a red giant is a star that has exhausted its hydrogen fuel and is now fusing heavier elements. This process causes the star to expand and cool down, giving it a reddish appearance. The life of a red giant is a tumultuous one, with the core contracting and the temperature rising continuously until fusion can no longer occur. The fate of the star then depends on its mass, with smaller stars leaving behind white dwarfs and larger ones ending in supernova explosions. Understanding red giants provides insights into the life cycle of stars and the future of our own sun. It offers a glimpse into the fascinating world of stellar evolution, where stars are born, live, and die in a cosmic dance of energy and matter. It's a reminder of the transience of existence and the grandeur of the cosmos. So the next time you gaze up at the night sky, remember the red giants, those fiery celestial beings that embody the turbulent yet magnificent life of a star.